Yeah, so for anyone watching this video, this is basically going to be about voltage drop testing, which is just one of the skills you have to have nowadays to be an automotive tech. If you do any kind of electrical troubleshooting or any kind of diagnostics related to electronic problems, um, voltage drop testing is something you have to know to be able to accurately diagnose electronic problems. So I figured I would just do this video on it for a bunch of reasons, a bunch of different reasons. Um, I post videos like this to kind of like show off maybe my tools or things I know, or to maybe attract new customers, because I was doing mobile work I've done mobile work on and off for a lot of years and worked in different shops. But long story behind that I won't go into, but I do it videos like this to kind of, attract customers or work, or maybe even a shop might want to hire me, or maybe attract some new subscribers to my channel. But also why I do this is to hopefully help somebody else out there that's trying to learn stuff like this or wants to learn stuff like this. And in the process of me trying to make videos like this, it actually makes me have to learn much more and understand this kind of stuff much better. So really, in a roundabout way, it actually makes me better at doing diagnostic stuff and learning and knowing all this electrical stuff and electrical testing stuff and circuit stuff and everything to do with electrical type diagnostics. But I'm definitely no expert in this, or no expert in anything. And I know there's all kinds of other channels and resources where you can learn about stuff like this in much more detail from much more experienced, knowledgeable guys than me. But I figured I would just do a little video on it and not go into it too deep. I could actually make hours of videos on this stuff. There's all kinds of ways you can do this voltage drop testing, all kinds of circuits you can rig up, and ways to show it and try to teach it. But I thought of a way that I thought might be kind of simpler to show, and for people to understand if they don't know anything about it, or maybe know a little bit but aren't quite sure. It's actually something that's pretty easy to understand the general idea of what it is and how it works. But as far as learning to be able to actually know how to test for it, especially when you are actually working on a customer's vehicle and you're not quite sure if you're testing it right, or how to actually do this voltage drop testing, or what your meters are telling you. It's much different when you're actually trying to do it than just having an idea of what it is and how it works. It's much more. You don't really learn how to do it until you actually do it. You don't really learn about it really until you do it. And for me, I've studied it a lot and practiced it a lot, and I still get confused on it. But I don't work on vehicles every day. I don't diagnose electrical problems on vehicles every day. But I still have to go back and practice it every once in a while. And seems like it's something you have to do as an electrical type of diagnostic auto tech. It seems like you have to go back and review basic electrical stuff that you might have learned years ago, because a lot of things you forget. But anyway, I could ramble on about this forever, but I will show you basically what I was gonna show and try to get on video is I'm basically just going to do some voltage drop testing with my test light here. This is an old Craftsman test lights. This thing's like over 20 years old. I think it might actually have the original bulb in it. I'm not sure. I don't remember if I ever replaced the bulb in it. But this is an old test light. But what I got going on now is I got battery power coming from this Go Diag tool on this yellow wire. That's battery power. So it would basically be like the positive battery post on a vehicle. And it does have about 12 volts. It has 11.92, which is probably 12, because this meter's old too. This meter's about as old as this test light, and it reads sometimes like 1 or 2 tenths lower than most meters or some meters. So it probably is actually about 12 volts. But and I've got the negative lead hooked up to ground here. I've got the test light hooked up to ground here, and this is the ground going to the Go Diag box. So if I touch this test light here to that power lead, you can see we get a nice bright test light. The voltage drops to 11.75, which we were at started at about 11.93, which they would call source voltage. And trying to turn on my amp clamp here. It's hard to do all this stuff with one hand, but I gotta hold my phone in one hand. So I'll touch this again here to that power, and it's showing about 155 milliamps of current draw, which you don't have to have a current clamp or measure current or amps to do voltage drop testing, but they kind of go hand in hand. It's good to know how the voltage and the current work together, and how a voltage drop affects current flow. So that's kind of why I just threw that in there, so people out there might get a better understanding of it. But I've got this show you. So we're starting out again now. It's an open circuit, 11.94 volts source voltage. And now if I touch it to that resistor right there, we got a test light, but it's not as bright. Not nearly as bright as right there without the resistor in the circuit. Now we only got that, and we only have a 79 milliamp draw now going through the test light, going through that circuit, and the voltage is 11.85. So this voltage is measuring the whole the whole voltage drop across this circuit, across the test light and across the resistor. So right there without the resistor, it's that's looks like 11.71, but it's actually 11.77, because that top line on this meter doesn't work anymore. So that's 11.77. We started out about 11.93 or 4. 95 right there. So that would be 11.7795, about 180 millivolts difference from what we started with at this 11.95 or so, 934. And then with the resistor, 11.86, it's actually dropping more voltage. More voltage is getting used up across the circuit because we have the 100 ohm resistor in there. But you can see how just this 100 ohm resistor affects the test light. It's, you know, much dimmer and only drawn about half of the amperage. So that's that's an example there of how voltage drop can affect whatever it is that is being turned on a vehicle, like whether it's a headlight or, you know, anything, a blower motor, you know, a solenoid, a fuel injector, anything. Just a little bit of resistance that causes some type of voltage drop that shouldn't be there will affect whatever it is, whatever the load is, the light, or, you know, a fuel injector, you know, blower motor, whatever it is, starter, whatever it is. The voltage drop can have a big effect on it, even if it's some kind of small resistance. Like a 100 ohm resistor doesn't really seem like a whole lot of resistance on a 12 volt circuit, but I can show you it actually does make a huge difference. If I change where my meter's at, and I measure it right here, that's measuring across the resistor to my red lead, across that resistor. It's 8.34, 8.32, 8.32 or 4 or something. I'm not making a real good connection there, but that basically means 8.32 or 4 volts are getting used up by that resistor. It's taking 8.32 of the volts of the original about 12 we started with to get across that resistor. So that's a huge difference, you know, 8.32 out of about 12, you know. That's whatever percent that is, about about 66% maybe, or something, 2/3 maybe. It's a lot. But I'll show you here if now I'm measuring the voltage drop from past that resistor through the light to ground. Now we only have 3.5 volts of voltage drop. So basically only 3.5 volts is getting supplied and used by this light, which this light is actually a 6 and 12 volt light. It can run off 6 volts or 12 volts, but it's running off 3.5 right now. So that's why it's not lit up fully as bright as it could be. And it's only drawn the 80 milliamps. So we got 3.56 there. and the 8.32. But what I'll show you, I'll have to pause the video for a second, and I'll show you how that will affect the ground side of the circuit if I rig this resistor on the ground side of the circuit. Okay, so now I have the resistor rigged up on the ground side of the circuit right here. And I got my multimeter negative lead past that to that ground wire going to the Go Diag tool. And I have the test light hooked up, and we're still drawing about 80 milliamps and still have about the same voltage as we had before across the total load. But I'll show you what. Well, I guess I could have left that one there. See, I still get confused on doing this stuff. So if I move my negative lead here, that will tell us the voltage drop just across the light without the resistor. So it's 3.62, which is about the same thing we had with the resistor on the positive end of the circuit. And if I move my positive lead across the resistor, that'll measure the voltage drop across this resistor, which is 8.26. About the same thing we had with it hooked up on the positive side of the circuit. And well, actually I already showed it. But depending on who teaches it or how they teach it, I've heard it taught both ways, that and you can kind of look at it both ways. That say we hook the negative lead here and hook our positive lead just right on the other side of the resistor. So we're going to ground and just on the other side of the resistor. So we have 8.27 volts. So you could look at that as this is the amount of voltage you have here, potential voltage. That's kind of the way I look at it sometimes. It's almost kind of interchangeable, at least in my mind, and that's where it sometimes can get a little confusing and hard to understand. Whether you look at it as voltage drop or you look at this as a potential 8.21 or 27 volts sitting there from ground to there, you got a potential 8.27. But that's, it's taught as this is the voltage drop. Whatever's on the meter, that's your voltage drop. So that's just another way to look at it, and I probably shouldn't even have thrown that in there because that might have confused some people. But there's another thing I was going to show here, but I'm going to have to pause it again. Okay, so now I am hooked up to a different circuit. I disconnected from that 12-volt battery circuit, and I hooked up to this circuit right here, which is actually the 5-volt reference circuit for this module. This is an old bad module out of a 2000 Expedition, but I just use it for testing purposes and practice. But I'm gonna turn off my headlight here. So I got the voltmeter hooked on that 5-volt reference wire circuit, and we have 4.9 volts, which sometimes I just call that 5 volts. And I hooked the amp clamp up on that wire also. So now we'll see what we get on that this circuit. So that's what the light looks like. And we actually have 98 milliamps of current flow. So that's kind of interesting that there's 98 amps in that other on that 12-volt circuit. There was 80 amps. But also I took the well, that's without the 100 ohm resistor added in. So we'll see what that does. Okay, that's interesting. The light is actually not lit up, but it's showing 42 milliamps of flow. But there is no light. I'll take it off here. Nothing. Put it back on. So I'll see what our this might be hard to do here. Get an alligator clip on here. So we'll see what our voltage drop is now across this resistor on this 5-volt reference circuit. Four volts. 4 volts. So like I was saying earlier, let me see if I'm right about this. It might be the exact opposite. Okay, yeah, I'm the exact opposite. But like I was saying earlier, I could just hook to this light. We got 880 millivolts, almost 1 volt. So you could look at that as you have 1 volt of potential voltage there, but that is actually the voltage drop across the test light. Even though the light is not lit, it's using up that 0.88 volts to get for the voltage to push that current through the test light. So I'm not sure what else I can add to this. It's already getting pretty long. It's like 25 minutes now. Let me pause it for a second. Yeah, so I couldn't really think of anything else I wanted to add to this, and this video is getting long. I'm at the 25-minute mark, so I think I'm just gonna end it right here. But I did have all kinds of other ideas and about voltage drop testing I could show, and I actually have done a lot of different voltage drop testing the last couple days, and I keep coming up with all kinds of other ideas on stuff I can do videos on and testing stuff I can show. And yeah, I have all kinds of ideas. I could probably do a video every day for a while, because like the more I do, and the more I think about this stuff, I keep thinking up more tests I can do, and different things to test in different ways. So I'll be doing a bunch more videos in the future here, but that's all I'm gonna do on this one. And hopefully someone out there liked it. Hopefully I didn't confuse anyone out there, and hopefully somebody learned something, even if it was the smallest slightest thing that might be helpful to them. But yep, that's all I got for this one, and I will talk to you on the next one.